Okay, so for the first one, it asks, or it says it reaches a top speed of 25 meters per second. How far does it travel in 4 seconds at that speed? So we know that the speed is 25 meters per second. Okay, we know that the time is 4 seconds because seconds is a measure of time. And it says, how far does it travel? So when it says how far, it's talking about the distance. So it's wanting us to find the distance. So we're gonna use that speed formula, and we're gonna do speed is distance divided by time. So we're just gonna put the right stuff in the right places. So I'm gonna put 25 meters per second in for our speed. I don't know the distance, but I do know the time is 4 seconds. And I'm gonna try to solve for D here. What's keeping D from being by itself? What's on the same side as the D that we need to get rid of? What is it? The S, the 4 seconds, right? So how do I undo dividing by 4 seconds? What'd you say? Yeah, I'm gonna multiply both sides by 4 seconds. So I'm just gonna multiply both of these sides by 4 seconds. That undoes it. It's since they undo each other, they're opposites. Those undo each other. Multiplying by 4 seconds, dividing by 4 seconds, cancel out, and we're left with D by itself. And then what's 4 times 25? What's 4 quarters? 4 quarters make up how much money? $1, right? So 4 times 25 is 100, sorry, 100. 4 times 25 is gonna be 100. And seconds times meters per second, what happens with those units is, I'm gonna zoom in on that a little bit. What happens with those units, so we did 4 times 25, that's 100, and then seconds times meters per second. The seconds on top and the seconds on bottom cancel out with our units, and that just leaves us with meters as our units. Does meters make sense as a unit for distance? Does meters make sense as a unit for distance? Yeah, it does. Okay, so that's a good way to check, is if you end up with the right units in the end, that means you probably did it right. Cool. Okay. Will you guys do me a favor and circle your answers as you find them? That really helps me when I'm looking at these to see if you know what you're doing, especially since there's not enough space to work from the top down. Since you have to keep working from left to right, it's hard to see sometimes. Okay, let's see here. Let's do another one. Okay, so we use the formula speed equals distance divided by time. The next one's talking about acceleration. So you're gonna need your acceleration formula for that. Acceleration is velocity divided by time. That's gonna be our acceleration formula. I'll add that to the board too. Okay. And knowing that formula, I'm gonna let you guys go ahead and give that a shot. You're gonna be using the acceleration formula. So I would list out to the side, like, what's my acceleration, what's my velocity, and what's my time, and then I'd put the right stuff in the right places for that formula. Okay, I need to grab attendance really quick, but I'm gonna go ahead and give you guys a second to do that, and then I'll help you work through it if you're stuck, okay? So go ahead and work through that. Yeah. Here we go. I was gonna say, they've gotta be here somewhere. There you go. Make sure you do the closest one. If it's locked, go downstairs. Don't go up, okay? Okay. Yeah, what's up?
When she comes back, can I go to the bathroom?
Yeah, yep, as soon as she gets back. Do you want to go ahead and fill out your pass and leave the time blank and I'll sign it for you then, okay? Okay, let's go through, hold on, let me do one more thing and then we'll go through it. Okay. Cool. Let's do this. So just when she comes back, add the time to that, okay? Okay, so a bumper car accelerates from rest to 6 meters per second in 3 seconds. So our velocity, I should have put change in velocity for this. Change in velocity over change in time, okay? Change in velocity over change in time. That's what that delta means. Sorry, I should have squeezed it in there. So the velocity here, it goes from rest to 6 meters per second. That means that the change in velocity is going to be 6 meters per second minus rest, which is 0 meters per second. It's probably going to end up being the same thing that you guys did anyways, because 6 minus 0 is still going to be 0. So if you plugged in a velocity, you probably plugged in 6. So the acceleration, it accelerated from 0 to 6. So 6 minus 0 is going to be 6 in 3 seconds total. So that would be in the bottom 3 seconds. So my velocity difference, 6 minus 0 is just 6 still. So this one worked out even if you forgot to subtract it. So you'll end up with 6 meters per second, because 6 minus 0 is 6, divided by 3 seconds. Okay, well, 6 divided by 3 is going to be 2. And on this, we end up with meters per second, which is how we get meters per second squared for our acceleration. The seconds don't cancel out because this seconds on the bottom, it is on the bottom and the seconds is on the top of that fraction, like within the fraction. That seconds would be on top of a silent 1. So they don't end up canceling out there, okay? So we end up with 2 meters per second squared. So our acceleration is 2 meters per second squared. I should have filled this in. Our change in velocity was 6 meters per second. And our change in time was 3 seconds. Okay. Okay. Did I lose anyone there? Anyone need clarification? Okay, cool.